Hello. In this video, I'm going to be talking about Wigger's diagrams and how to interpret them, how to understand what's going on. Before I really start talking about it, I'd just like to direct your attention to the board. At the top of the board, we have our pressure curves. In green is aortic pressure, blue is left ventricular pressure, red is left atrial pressure. Right here we have our sonogram. That's not always seen on Wigger's diagram, but I've included it, and we'll talk about why in a little bit. Down here we have our EKG, and this is our left ventricular volume curve right here in black. So there are 7 different time periods that we need to understand, and we're going to talk about those right now. So first, time period A. That is called atrial systole. What's happening? So during atrial systole, this is the first part of our heart's contraction. So just remember that the atria contract first, and then our ventricles contract. So this is when our atria are actually contracting. Just before our atria contract, our heart is in this kind of steady state. The pressures between the left ventricle and the left atria are balanced. The aortic valve is closed, so the blood is just sitting in the ventricle for the most part, but there is some blood left in the atria. And this atrial systole, what that serves to do is eject a bolus of blood from the right atria into the right ventricle. So we start out at about 130 milliliters of blood, typically, in the left ventricle, and at the end of atrial systole, we have 140 milliliters of blood there, okay? That's all that happens in atrial systole. Our next step, time course B, is isovolumetric contraction. So what's happening at this point? In order to understand this, it's first important to recall that in order for flow to occur, there has to be a pressure differential. What does that mean? Essentially, in order for blood to get from one place to another, the pressure in place A has to be higher than the pressure in place B. And if we look here at our pressure curve, at the beginning of time course B, our ventricular pressure is really quite low, okay? It's hanging out at about 10 millimeters of mercury. But our ventricular pressure is all the way up here at about 80 to 90 millimeters of mercury. So in order for the blood that we have in our left ventricle to get out into the aorta, we need to meet and exceed that 80 millimeters of mercury. So what happens? Our heart during time course B contracts, but both the mitral valve and the aortic valve are now closed. So it's just contracting, increasing the pressure on the blood that's stored in the left ventricle until that pressure exceeds the pressure in the aorta. At that point, once it exceeds the pressure in the aorta, the aortic valve will open and blood will rush into the aorta. Now, our left ventricle isn't finished contracting yet. It's going to continue to contract, and that takes us into time course C. Our heart continues to contract, pushing blood out, increasing the pressure of both the ventricle and the aorta, okay? So our pressure goes up from about 80-ish, 80 millimeters of mercury, all the way up to 120 millimeters of mercury in the in time course C. And we can see at the same time our volume is rapidly decreasing. Time course C is called rapid ejection. We're rapidly ejecting blood from the ventricles. In time course D, we continue to eject blood from the ventricles, but not as quickly as before. It's reduced ejection. And we see also associated with that reduced ejection, a reduced pressure, okay? Now let's go ahead and let's talk about what happens at time course E. So between D and E, our aortic leaflets close again. Our aortic valve closes back up. That's to prevent backflow, okay, of blood. And time course E is our isovolumetric relaxation. So what's happening? Essentially, the volume of blood found in the left ventricle is not changing at all, but the muscle itself is relaxing, okay? And so we're going to see a decrease in pressure. It's going to come all the way back down to match left atrial pressure. And we're also going to see that there's no change in volume there. And then it actually is going to relax below the pressure in the atria, which will allow blood from the atria to flood into the ventricles, and we start to get this rapid filling of the left ventricle, which is then followed by a slower filling, a reduced filling of the left ventricle. That's G there, okay? And that is pretty much everything you need to know for Wigger's, for a normal Wigger's diagram. Actually, one last thing, just make note of the average pressure. So aortic pressure is going to hang out pretty close to 100 millimeters of mercury on average, and our left atrial pressure is going to hang out below 10 millimeters of mercury, so somewhere 4 to 6 millimeters of mercury probably on average. And I'll go ahead and pick this up in another video.